After reviewing the required concepts for this topic, we are going to start our main part, which is a microwave amplifier design. We start this section with the two-port network. So before going into details, into some formulas and calculations, we are going to talk about this two-port network. So we will understand what is the two-port network, what we have in our source, what we have in our load, and what kind of waves we have, the reflection coefficient, the waves. So we're going to cover these things in this topic. So this is the very general figure that we have for our two-port network, and we say the two-port network with arbitrary source and load impedances. It means that for now we don't care about ZS and ZL. We can have different values here. The idea is actually in order to understand the system rather than doing some calculations and putting the optimum impedances here. So we start with the left part for this the network for the system. So at the left part we are going to have our source, the power source. So the power source is actually this part, as you see. So you can imagine this power source as a black box. This power source is delivering power to our two-port network, and this is our two-port network. So two-port network here, and this can be our amplifier or LNA. So this LNA pulls power from this power source. This is the power source. There's something confusing here because as you see there's VS and ZS here, so we'll avoid analyzing this circuit with voltage and current because we always care about the power quantities, and we have to characterize our power source. We have to know what is the behavior of power source. That's why you can imagine this, after that you can imagine this as a black box. So it's not like that you open this, there's a source, you open, there's a ZS, you can remove it, get rid of it. No, this is just a mathematical model you can use, but we are going to assume this as the power source which gives the power to our network. So let's see what is happening here. So this source has ZS, the impedance, and this network has also the input impedance. So we have input impedance Z in, and also it has the output impedance Z out. So up to here we know everything about this one. So let's see how this two-port network pulls power from this source. So what we have here, the Z in is going to be load for this power source in our circuit. It means that you can imagine like this. So we have a black box, we have something like this, we call this power source, and this power source is terminated by impedance, and this impedance is actually our Z in. Yeah, how can we pull the maximum power from this source, or how we can have this source, or let's say make this source to produce us the maximum power? What is the where we have to see where is this maximum power, the maximum power which is delivered to this impedance, to this Z in. And we actually talked about this in previous courses. We said that this is actually the maximum power. We are talking about the average power which is delivered to this, which is going to be the half of real part of the voltage of this node. Let's say V, I don't care for now, and the conjugate of the I. So V and conjugate I, the current which is going into this impedance. So this is when we talk about the max power, we talk about this average power which is delivered to the input impedance of our network. So now the question. Thank you for watching our video. Please don't forget to subscribe. You can learn about this topic and more using our website. The complete course on this topic is provided on our website at www.rahsoft.com. Rahsoft is providing a complete certificate on radio frequency. The courses are complete step-by-step approach with quiz and examples, and certificate of completion will be provided upon finishing each course. By taking the required courses in RF system and IC design with pass status, Rahsoft would provide the Rahsoft radio frequency certificate. Thank you. See you soon.